Something impossible is happening inside a sealed tube in northern China right now. A train floating on invisible magnetic fields, hurtling through near-airless tunnels at speeds that make commercial airplanes look slow. While the rest of the world abandoned this technology as science fiction, China just made it real. The T-flight has already shattered every speed record for maglev vehicles on Earth, hitting 623 kilometers per hour on a track barely 2 kilometers long. But here's what's truly mind-bending. That's not even close to its final form. Today, I'm breaking down the 8 revolutionary breakthroughs behind China's vacuum tube train, including why their ultimate target of 4,000 kilometers per hour could redefine human transportation forever. Stay until the end, because number 1 reveals technology that shouldn't exist yet. Number 8, the invisible enemy. Before we talk about the train itself, you need to understand the force that has limited ground transportation since the beginning of human civilization: air. It sounds harmless, but at high speeds, air becomes a wall. At 300 kilometers per hour, roughly 80% of a train's energy goes to fighting air resistance alone. And here's what makes it brutal. Aerodynamic drag doesn't increase gradually. It increases with the square of your speed. The power needed to overcome it, that increases with the cube. This is why commercial jets fly at 10,000 meters altitude, where the air is 4 times thinner. A Boeing 737 cruises at around 850 kilometers per hour up there. But try that speed at ground level, where air density hits 1.25 kilograms per cubic meter, and you're essentially pushing through liquid. The T-flight solves this with something that sounds impossible. It removes the air entirely. The train operates inside sealed tubes where pressure drops to approximately 100 pascals. That's roughly 1/10 of 1% of normal atmospheric pressure. At this level, air resistance virtually disappears. We're talking a reduction of over 99%. To put that in perspective, accelerating from 900 to 950 kilometers per hour in near vacuum takes roughly the same energy as going from 50 to 100 in normal air. This single innovation transforms ground transportation from fighting physics to working with it, and China just built it. Number 7, superconducting levitation. With air eliminated, the T-flight attacks the next enemy, friction, and it eliminates that too by never touching the track at all. The train floats on magnetic fields so powerful they seem to defy gravity itself. Here's how it works. Superconducting magnets on board the vehicle are cooled to negative 269 degrees Celsius using liquid helium. At these extreme temperatures, something remarkable happens. Electrical resistance drops to nearly zero, and the magnets generate fields 10 times stronger than ordinary electromagnets. These fields interact with coils embedded in the guideway walls, creating forces that lift the train, keep it centered, and push it forward simultaneously. Japan's L0 series maglev floats 10 centimeters above its track using similar technology. The T-flight takes this proven system and places it inside a vacuum tube. No wheels means no rolling friction. No friction means no wear on components. No contact means no mechanical noise. The train glides through the tunnel like a hockey puck on an air table, except the cushion isn't air. It's pure magnetic force. By combining vacuum tubes with superconducting levitation, China has eliminated the two forces that have limited ground transportation since humans invented the wheel. The result is a vehicle with almost nothing holding it back. Number 6. the Datong Test Facility. Revolutionary technology demands revolutionary infrastructure, and China built something the world has never seen. Located in Yangao County, Datong, in Shanxi Province, the T-Flight Test Facility is the longest vacuum tube maglev track ever constructed on Earth. Construction began in April 2022, and by November 2023, the main structure was complete. 2 kilometers of sealed tubing capable of maintaining near vacuum conditions, while a superconducting train hurtles through at record speeds. But here's what's truly mind-bending. The precision required to make this work borders on obsessive. Size differences across the entire 2-kilometer tube are controlled to less than 2 millimeters. The track flatness tolerance is 0.3 millimeters. That's smoother than polished glass, maintained across a structure longer than 20 football fields. China Railway's 6th Bureau Group built 1.55 kilometers of the line, and engineers described it as the most challenging mission in their company's history. Maintaining a vacuum seal across this distance while ensuring the track remains perfectly aligned for magnetic levitation seemed impossible until they did it. Phase 2 will extend this track to 60 kilometers, long enough to test the train at its full target speed of 1,000 kilometers per hour. This isn't just a test track. It's proof that the impossible infrastructure already exists. Number 5. Breaking records. The Datong facility hasn't just tested theories, it has rewritten the record books. In February 2024, the T-Flight achieved 623 kilometers per hour on its 2-kilometer track. That's a world record for superconducting maglev vehicles, surpassing Japan's legendary L0 series, which hit 603 kilometers per hour back in 2015. But here's what's crazy. The T-Flight set that record without vacuum conditions. Just a train, a track, and raw magnetic power in normal atmospheric pressure. By August 2024, engineers conducted the first successful test under low vacuum conditions. Every system performed flawlessly. Stable magnetic levitation, controlled navigation, safe braking. The train's trajectory matched theoretical calculations with precision that left engineers speechless. And it gets more impressive. In 2023, an electromagnetic sled experiment at the same facility reached 1,030 kilometers per hour. That's supersonic propulsion technology, already proven, waiting to be integrated into the passenger vehicle. To put this in perspective, a commercial Boeing 737 cruises at around 850 kilometers per hour. The T-Flight achieved comparable speed on the ground, on a track so short it had to accelerate at roughly 1 g, the same force you feel during freefall. These aren't projections or computer simulations. China has already built a ground vehicle that matches jet speed. Number 4. The missile makers. The organization building the T-Flight isn't a railway company. It's China's largest manufacturer of missiles. The China Aerospace Science and Industry Corporation, known as CASIC, leads this entire project. Founded in 1956 as the 5th Academy of the Ministry of Defense, CASIC designs and produces strategic missiles, cruise missiles, tactical weapons, and space technology. They employ over 145,000 people and control assets exceeding $44 billion. So why is a missile manufacturer building trains? Because the physics of launching projectiles at hypersonic speeds isn't so different from propelling passengers through vacuum tubes. The same engineers who design weapons capable of traveling at Mach 5 are now applying that expertise to civilian transportation. And unlike private companies chasing quarterly profits, CASIC operates as a state-owned enterprise with government backing. The Shaanxi provincial government co-develops the project. State banks provide financing. There are no shareholders demanding quick returns, no venture capital runways burning down. CASIC's commercial aerospace initiative places T-Flight alongside satellite constellations and space launch systems as priority projects. When your train is built by rocket scientists with unlimited government patience and no profit deadline, 1,000 kilometers per hour stops being a fantasy. It becomes an engineering problem, and CASIC solves engineering problems. Number 3. Shrinking China. Speed isn't just about numbers. It's about transforming how an entire nation connects. Right now, Beijing to Shanghai takes 4.5 hours on China's fastest bullet trains. The T-Flight could cut that to just 90 minutes. Beijing to Datong, currently a 4-hour drive, would take under 30 minutes. At 1,000 kilometers per hour, a 400-kilometer journey becomes shorter than your morning commute. China already operates the world's largest high-speed rail network, exceeding 38,000 kilometers of track. T-Flight represents the next evolution, and unlike air travel, there's no airport commute, no security lines, no boarding delays. You arrive at the station, board the train, and reach another city before your coffee gets cold. Passengers would maintain 5G connectivity throughout the journey. Associate Professor Jonathan Kuldrick estimates that shifting regional flights to ultra-high-speed rail could reduce carbon emissions by 3 to 4% in some nations. The environmental case is as compelling as the convenience. T-Flight doesn't just save time, it makes geography irrelevant. Morning coffee in Beijing, lunch meeting in Shanghai, all before noon. Number 2. Why China succeeds. The Hyperloop dream died in America, but China made it real. Here's why. Hyperloop 1 raised over $450 million since 2014. Richard Branson invested. Virgin attached their name. The promises were massive. And on December 31st, 2023, the company shut down forever. Their best crewed test reached just 172 kilometers per hour. That's less than 15% of their design goal. They never secured a single contract to build a working system. The problem wasn't technology. It was economics. Private capital demands quick returns. Vacuum tube infrastructure takes decades to become profitable. Investors lose patience. Companies collapse. China's approach is fundamentally different. CASIC is state-owned. Shaanxi province co-develops the project. State banks provide financing with no quarterly earnings pressure. Germany's Tiam Hyperloop reached 463 kilometers per hour in testing. Impressive. But T-Flight hits 623 kilometers per hour and keeps accelerating. While Western companies burned through hundreds of millions chasing investor returns, China quietly built the world's most advanced maglev test facility. The difference isn't technology, it's commitment. And commitment is something state-backed projects never run out of. Number 1. The 4,000 kilometer per hour vision. 1,000 kilometers per hour is just the beginning. CASIC's true ambition makes that look slow. Phase 2 extends the track to 60 kilometers, enough to reach the full target speed of 1,000 kilometers per hour. But Phase 3 is where it gets terrifying. 4,000 kilometers per hour. That's over 3 times the speed of sound. The SR-71 Blackbird, the fastest crewed aircraft ever built, maxed out at 3,540 kilometers per hour. The T-flight aims to surpass it. On the ground, at 4,000 kilometers per hour, Beijing to Shanghai becomes an 18-minute trip. And here's what makes vacuum tubes perfect for these speeds. No air means no sonic boom. The shock waves that make supersonic flight so problematic simply don't exist when there's nothing to compress. Theoretical physics studies suggest vacuum trains could eventually reach 6,400 to 8,000 kilometers per hour. At those speeds, intercontinental networks could circle the globe in hours. New York to London without leaving the ground. Tokyo to Paris before lunch. The T-flight isn't just a train. It's the prototype for a transportation system that could make anywhere on Earth just a few hours away. And China is building it right now. What we've just witnessed isn't science fiction anymore. Inside a vacuum tube in northern China, a vehicle built by missile engineers is already traveling faster than commercial jets, and they're just getting started. While Western Hyperloop companies burned through hundreds of millions only to collapse, China quietly built the infrastructure, broke the records, and set their sights on speeds that would make supersonic aircraft jealous. The question isn't whether vacuum tube trains will work. They already do. The question is how fast they'll get and whether the rest of the world can catch up before China connects its megacities in minutes instead of hours. Which breakthrough impressed you most? Would you ride a train at 1,000 kilometers per hour? Let me know in the comments and subscribe for more.